curve C has the equation y equals x minus 3x to the power of a half plus 3 passes through the point P, which is 4, 1. We need to show that the tangent to the curve at P passes through the origin. So tangent, I'm thinking y equals mx plus c. So I want to differentiate my function here to get the gradient function. So when I differentiate, I get dy by dx is equal to, the x will differentiate to be 1, the minus 3x to the power of a half, we're going to multiply by the half, so we'll have minus 3 times a half is minus 3 over 2. We'll then take 1 away from the power, so a half take away 1 is minus a half, and the 3 will differentiate to be 0. So this is our gradient function. I'm now going to work out what the gradient is when x is 4. So when x is 4, my gradient dy by dx is equal to 1 minus 3 over 2 times 4 to the power of minus 1/2. So that's 1 minus 3/4 is 1/4. So the gradient of the curve, and therefore the gradient of the tangent at P, is 1/4. So y equals mx plus c. We know that y is 1 when x is 4. So let's substitute that in. Y is 1 when x is 4. So therefore c is 0. So the equation of my tangent is y equals 1/4 x plus 0. And I can now say that y-intercept is 0. So passes through the origin. And that's part A done. We're then told that the normal to the curve at point P crosses the y-axis at point Q. So normal makes me think perpendicular and negative reciprocal. At the same point, now we know the gradient of the tangent at that point is 1/4. So therefore the gradient of the normal at that point is the negative reciprocal of 1/4, which is minus 4. So my normal would look like y equals minus 4x plus c. We're still talking about the normal at point P. So I know that y is 1 when x is 4. So c is 17. And the equation of my normal is y equals minus 4x plus 17. So crossing the y-axis at point Q, point Q is the coordinate 0, 17. Part B, find the area of OPQ. So I'm just going to draw a little sketch here, just to help me out, just to picture exactly what's happening. Point O is the origin. Point P is the coordinate 4, 1. And point Q is the coordinate 17, 0, 17. So this is the triangle that we're trying to work out the area of. I know the base of this triangle is 17. The height of this triangle will be the same as the x coordinate there, so 4. So the area of this triangle, half times base times the height, and we get 34 units squared.